Hello everyone, we're going to start 8.2, we're going to skip 8.1 and we're going to do the Pythagorean theorem and its converse. You guys are very good at the Pythagorean theorem, so we're not going to spend much time on that, but we're going to be able to find different properties of it. So before we begin Pythagorean theorem, I want to review simplifying square roots. And I'm going to pause the video because my dog is whining. Hold on. Okay, so I gave you a sheet full of all the perfect square roots. So what you're going to do is it's kind of like prime factorization, if you remember the factor tree. But we're going to create a factor tree with, or a prime factorization tree with square roots. Okay? So, and what you always want to look for, remember with prime factorization, you're always looking for prime numbers. But with square roots, we're always going to be looking for perfect squares. So do we know of a perfect square that goes into 40? Well, yeah, 4. 4 is a perfect square. So we can times that by 10. So if we were to split this up, the square root of 4 is 2. Now what about the square root of 10? Is there any perfect squares that go into 10? No. 2 and 5 are not perfect squares. Because if you were to take the square root of them, you get decimals. And the square root of 10, well, that's decimals as well. So we're going to leave it as 2 square roots of 10. Let's try another one. What about the square root of 200? Do you know a perfect square that goes into 200? 100. So the square root of 100 is 10. And the square root of 2 we're going to leave as the square root of 2. Let's do some more practice. What about 261? Perfect squares. I would just go down the list and see which ones you can find. You're going to notice 9 goes into 261 29 times. So it's going to be 3 square roots of 29. What about 30? Perfect square going to 30? Nope. So it's just going to be the square root of 30. Okay? And we'll go over this some more. Feel free to watch this over again, rewind and replay this concept again, because I don't want you writing decimals anymore. If it can be simplified into a square root, the perfect squares, you're going to do that from now on. So the Pythagorean theorem we know is a squared plus b squared equals c squared. A and b are the legs. C is across from the 90 degrees. You guys already have this written down in your notes. You already know how to do this. Well, there's some special Pythagorean triple triangles, meaning that if I have 3 and 4 as the legs, I automatically know 5 is going to be the hypotenuse. Same thing with 5, 12, and 13. 5 and 12 are the legs, automatically 13 is going to be the hypotenuse. 8, 15, and 17 always make a right triangle. 7, 24, and 25 always make a right triangle. So if you find 3 numbers that are multiples of these Pythagorean triples, you know that you're going to get a right triangle. Okay? So here's some examples that I want to try. 48 and 20, can we find x using the Pythagorean triple? So are 48 and 20 multiples of anything on the previous slide? Any of these? Well, let's go ahead and divide by 4. Well, 48 divided by 4 is going to be 12, and 20 divided by 4 is going to be 5. So then x isn't just going to be 13, it's going to be 13 times 4, because all of these are multiples of 4 in this Pythagorean triple, 12, 5, and 13. So x is going to equal 52. What about this next one? Does it make anything on the previous slide, a Pythagorean triple? Well, remember, this is the hypotenuse here. So if we divide by 2, we'd get 7 and 25. So the missing one's going to be 24, but since we divided by 2, we need to times by 2 so it fits with the others. And so x is going to equal 48. So that's all I have for this video. I'm not going to have you do anything. I want you to go ahead and, if you have time, go ahead and move on to the next video. You guys have a great night. We'll see you later.